Hi everyone, Sam here from Retrotec, and today we're going to cover blower door assisted thermal imaging. And this is when you use a thermal camera along with the blower door to locate leaks in a building envelope. So the way we're going to do this today, as you can see here, I've got my iPad here beside me. I'm going to be using a prototype of the new Hype Micro M30 thermal camera that wirelessly connects to my iPad here, so that way I can create some nice clean thermal footage so that you guys can see what I'm seeing here in the lab. And what we're going to test is my airtightness test simulator here, and we are creating a delta T between inside the chamber and outside. So basically what we're doing is creating heat inside and cooling down the space around it. That way we're simulating a house in the winter season, creating that good delta T so that we're getting a warm interior and a cool exterior. So here you'll see that we have about a 20-degree delta T. So whenever you're doing thermal imaging in the field to look for air leaks, we recommend at least a 14-degree. But even if it's 10 degree, a lot of times you can still see a lot of the things that's going on. But the greater the difference is in temperature between inside and outside, the more likely you're going to see those problem areas caused by air leakage. Now notice that we have this space inside warmed up to about 89 degrees. Now I know nobody heats their house that warm, but the actual temperatures don't matter nearly as much as the differences between those temperatures inside and out. So within this laboratory setting here, that was the easiest way to create that delta T. That way we'll see those air leaks similar to what we would see in the field. So if you've ever seen any of these videos before using this same simulator, you'll notice that I've added some insulation here to some of these panels. That is to create a more realistic scenario for what you would see in the field, because most houses have insulation. There are some that don't. There's still a lot of older historic homes out there that haven't received that treatment that they would need to be more comfortable. But as you are going around doing this, I'm sure you'll probably be dealing with more modern style homes that have that insulation in the wall cavities. So that's why this is installed. And there are some areas that don't have it, such as these small spaces here in the front. You'll see that we can tell some differences here between what's air leakage that we can see coming out of this poorly sealed panel here versus thermal bridging that we can see here that's kind of a lighter glow. So that's one thing that I always recommend is it's important to be able to differentiate what you're actually seeing in a thermal image. And one thing that I always recommend, that if you're going to really apply this stuff to your daily work, try and get at least a level 1 thermographer certification. It's one of the best ways to get some good education to see how to use your thermal camera and how to interpret what you're seeing. Because it could be a number of things. If you see a discoloration in a wall assembly or a floor or a ceiling, you want to make sure that you know if it's air leakage, is it thermal bridging, is it moisture? It could be a number of things. So you want to be able to tell one thing from another. And we can look at a couple of things here and I can show some more examples. But mainly what we're going to focus on here today is being able to identify air leakage and what that'll look like. So I've done a couple of presentations before with a thermal imaging trainer out of the Green Bay area. His name's Jay Bowen. And for this demonstration, I'm going to kind of follow some of his guidelines that he recommends. So if you already know about blower door testing, if this is something you already do, then you know that whenever we do just a basic blower door test to be able to measure the leakage in the building, we create a 50 Pascal pressure differential between the inside and the outside of the space. But if you're going to use thermal imaging, you want to do that before you run your blower door test to measure leakage. The main reason is you don't want to over-exaggerate the leaks in the envelope before you shoot it with that thermal camera, because it kind of blurs everything. If you over-exaggerate those leaks like that, it can make it difficult to see exactly where that air leak is coming from. So one thing that Jay recommends, he recommends starting out low and then gradually working our way up. So in this demonstration, we'll start out at 5 pascals, then we'll jump to 10, then we'll jump to 25, and then we'll see what things look like at 50. And it's good to document what pressure the house is at whenever you take a thermal image or a thermal video. That just gives a good idea of the severity of that leak. And it's a good way to compare one leak to another. So this is the Hike Micro camera that we're going to be using. This is their M30 model that has the manual focus on here, which is nice, so you can use that to really dial in and get a nice clean photo. And there's some different settings we can use here. For example, there's different color palettes that we can use. So the iron bow is typically what we use, which is what I'll be using today, but you can change from black and white, or basically any type of color palette that you want to use, but we're just going to use that standard iron bow setting there. There's also some different ways to produce the thermal, so this is just the full thermal image that we can use. There's a thermal overlay where it actually looks at the object that you're pointing at and applies that thermal over that, so that way you can get a cleaner look of the object that you're pointing at along with the thermal attributes to it. Or you can have a picture-in-picture there where you can just kind of highlight some different things there in the middle. So to start off with, we have our blower door set up to pressurize this space. So if we are trying to capture thermal images from the outside of the building, then pressurizing is what we want to do, because what we want to do is force some of that warmer interior air outward so we can capture it coming out of the building envelope wherever it's leaking. But for most houses, what we're going to do is the opposite. So we'll stand inside the house and depressurize the space to bring that outdoor air in to see where it's coming inside. So in this video, I'll do both. Sometimes it just depends on the building that you're testing, and it depends on where that leakage is occurring, on where you want to capture that image. Sometimes it's nice just to do both and just see what you come up with. So I'll do an example of both of those today, but now we'll start out on the outside of this structure, and then we'll work our way in. So what we'll do first is just a quick scan around the building without the blower door running, and then we'll turn it up to 5 pascals of pressure. So as we walk around, we'll have it just on thermal mode here, and just take a quick look at some things. We see what will probably be some air leakage there around that corner. We see some thermal bridging where there's no insulation here. And as we come around the side, we can see what appears to be some thermal bridging between this insulation. If we change our view here, that's likely what that is. And that's the helpful thing about running the blower door. Whenever you increase pressure, if that hot or cold spot gets more and more severe, then that's a good indicator that what you're looking at is air leakage. And we can see some discoloration here around this door, which is likely due to air leakage due to a bad seal. And if we go back into thermal mode here, we can see the drastic difference between having an insulated wall section versus having an uninsulated wall section. And if you do this long enough, you'll definitely be scanning some rooms, exterior walls, ceilings, and floors, and you'll see these spots like this that don't have insulation. Whether if it's from some kind of repair in the ceiling where insulation got moved or didn't get put back, or maybe a stud bay got skipped. Every now and then you'll come across that. So now we've done our initial scan. We've seen some hot spots here from the outside. Some of it might be thermal bridging, some of it might be air leakage. So we'll go ahead and turn the blower door on now and see what changes we see just at a slight pressure of 5 pascals. So now we've got the gauge booted up here, and this is where it's handy to really use the gauge remote app from Retrotec to use with the DM32. So as you are increasing pressure in the house with the blower door, you don't have to run back to the fan every single time. You can just use your device, whether if it's a phone or a tablet, to increase that pressure to control the fan from anywhere in the house. So Here we'll go ahead and set our pressure to 5 pascals. So we'll go ahead and hit set pressure, 5, and hit set. And we'll create that 5 pascal pressure differential just to give us a slight pressurization on the building, just to exaggerate those leaks a little bit. So now we'll go back over and scan some more here with the camera. Now we can see already at 5 pascals, as we're scanning around this panel here, the air leakage around here due to the poor seals here already seems to be a bit more vivid. And that would make for a nice photo there. And as we're looking around the building, it's always important just to, it's good to scan the whole thing, but as you do this more and more often, you begin to look for some of the common culprits, where one material will meet another. And around this door panel here, we can see this leakage here to be more vivid than it was before we were running the blower door. And this seems to be about the same. So it's not as bright here as we see here. So this corner piece here seems to be thermal bridging. So now we'll bump it up a little bit. We'll use our jog button here to go up 5 pascals to take us from 5 to 10. Now these leakage areas are starting to intensify a little bit more, starting to stand out a little bit more. So we can see around there. And then as we come around to this panel here, we can see some. And now we can see a little spot here where these two panels meet, where there's a little bit of leakage coming out here at the top of the chamber. So now we'll go ahead and bump us up. Let's go to 25 pascals and see if anything new shows up. Now as we start applying pressure here, we can see this panel insert here on the front. We can see some hot spots starting to occur on these corners here that probably could be sealed a little bit better if we were really trying to get this chamber airtight. And as we look around here, if we look up towards the top, we can see some warm air starting to get pushed out towards the top here where these two panels meet on the front here. This is still looking the same, so we're comfortable with saying that this is likely not air leakage. This is thermal bridging happening where there's a gap between the insulation and that stud. Of course, this is starting to intensify a little more. We're starting to see that leak there at the top a little bit clearer. With this extra pressure here, now we can see this panel here starting to leak. This is a magnetic panel here that we use on the chamber. That way we can set it up as either an encapsulated or a vented attic. This one's closed, but now that we're at 25 pascals of pressure, we can see these seals start to leak a little bit more here. So this is kind of what I was talking about earlier, where it's nice to look at some leaks at different pressure ranges to see which ones are going to be more severe than others. Before when we were running at that low pressure, this panel here wasn't really showing up where we can see this leak now. So that tells us that that leak probably isn't going to matter as much as these seals here around the door. But in a real world scenario, doors and windows are always going to leak. A lot of times what we would be looking at are, the type of leaks that we constantly see in ceilings, through floors, things like that. Ceilings usually are going to be more leaky than other parts of the house, just with all the different kinds of penetrations we have going through there for mechanical, electrical, and plumbing. Also where we have those cracks where the ceiling drywall meets the top plates. So a lot of times that'll show up pretty easily too. And again, this is wintertime conditions. So if we were to flip things and have a cold interior space and a warm exterior space, all of these colors would be flipped. So we would see dark colors escaping here instead of warm colors escaping with this color palette. Now we'll go ahead and ramp it up to our full test pressure. We'll go ahead and bump everything up to 50 pascals just to see what it would look like there. Now at this pressure, we can really see this panel here starting to leak. It's becoming a more defined outline there with some of that interior air escaping. Of course, these outlines that have been leaking are becoming more vivid here now that we can see. And we'll flip to a different view here. We'll change over to this mode here. This type of view can be helpful just to really provide a clearer picture of what it is that we're actually looking at. Here, we'll flip back to thermal mode here. And we can see some more air leaks coming here out of this panel. This space here, we're starting to see leak a bit more. And around this panel as well. So now that the fan has been running at 50 pascals for a little while, I'm going to go ahead and shut the fan off. Now that everything is off, if I continue to look around, notice that everything is still pretty bright. It's because the surface temperatures around those areas that have been leaking have been warmed up by that interior air escaping. So we can still see this spot leaking where we didn't before we turned the fan on. Same for this panel here. These are still pretty vivid. Same around the leaks for this panel and this front window here and this front door. And it's for this reason why we don't want to run our blower door test at 50 pascals first and then do thermal. Because then we can't see the leaks build as we increase pressure slowly over time. We're not able to see the severity of some leaks compared to others because everything has already been lit up with that high pressure, and those surface temperatures that we're looking at are kind of stuck there for a while. We'll have to wait for the house to kind of cool back down to its natural state before we can do this again. So to really work through this faster, that's why it's better just to go ahead and do your thermal imaging first and collect all that data that you want, then run your test at 50 pascals.
So now I'm inside the chamber, and we're going to do the same thing that we did outside, but now looking at those leaks from the inside. So the color patterns that we're going to see are going to be the opposite, as I explained before. Now that we're in the warm interior space, we're going to see that cooler outdoor air move inward. So we'll go ahead and set our blower door to 5 pascals, and then we'll do that same pattern. We'll go 5, 10, 25, and then 50. So now we'll set to 5. And one thing that I did here was I did flip the fan around so that we're depressurizing the space. That way we're exaggerating those leaks across the envelope and bringing that air inward. That way we will see that cooler outdoor air come in on our thermal camera. So we've achieved that -5 pascal pressure differential. It's been running for just a little bit now. So let's take a look with our camera and see what we have here. Now we can see around this door panel, this is that front door that has that panel there in the middle, and we can see some air leakage coming in there underneath that insulation. and you can see it coming in across that stud there. Same up towards the top of the door, we can see some of that air moving inward. And we can see some of that dark coloration, that outdoor cooler air moving in through a poorly sealed panel there. Same on this door. With just that slight pressure differential, we can see some of this stuff happening here. We also have some panels in here that are simulating attic hatches, and I have one shut here to simulate a little bit of a leak here. And these are uninsulated, so we can see that around the edge of this it is warm, as that warm buoyant air has moved up. However, we can see some of that cool air start to come in and get in contact. So some of this blue that we see here, some of this is going to be thermal bridging, some of this is going to be air leakage. Since these panels aren't insulated, this is kind of simulating an uninsulated attic floor here. So this is when it'll help. We can bump up our blower door here and then see what exaggerates and what doesn't. So we'll go ahead and bump things up to 10 pascals, or negative 10 pascals, since we are depressurizing now. Now that we've achieved that, let's take a look back around some of these seals here. We can see some of these air leaks around this panel here start to intensify a bit. See that cool air move in across that stud and starting to come across the front of that insulation there. And let's look back at our ceiling panel to see what things are looking like there. Now we can see some of that cool air come in a little bit better. Looks like we've got a leak there on both sides. We've got some coming in that's cooling down that ceiling there beside the attic hatch, and we've got a little bit leaking there on that other side as well. And then these other kind of blue purple tones that are starting to show up. Again, that's just going to be some thermal bridging there, where that outdoor air is just coming into contact with that ceiling plate, since there's no insulation there to slow down that thermal bridging. Now we'll bump things up to 25 pascals, so we'll jog it up there. We hear our fan speed ramp up. Now we see these leaks start to stand out a bit more here. We see another one coming in here on this side panel. You see this discoloration here starting to happen further across the front of this insulation here, so we can see that here move across the front of this door panel down to this bottom side here, and across here at the top. You can really see that lower temperature starts to move across there as it's being pulled in by the blower door. And we'll take a look at our attic hatch here again. And now it's really starting to show up. would use your blower door when you're inside the home, which is typically how you're gonna do it. That way you can depressurize, walk around the house, you can have your fan control in one hand and have the camera in the other, and then look at some of the common culprits that we see, usually at the corners of the house, around different penetrations that go through the ceilings and the floors, same for exterior walls. And then those connections there at interior walls of the ceilings. That's usually where we see a lot of outdoor air coming inward as that blower door is running. Same for any kind of penetrations we see from porches and things like that. And beam pockets coming through the side of the house are usually a weak spot for air leakage as well.
Well, that wraps up this video on thermal imaging with the blower door. If you have any questions, please reach out to us at sales@retrotec.com or visit our website at retrotec.com, where you can see other kinds of educational material to make you work more efficiently in the field. Your feedback is welcome. We'd love to hear from you. Let us know what else you would like to see that might help you out as you work. And thank you for watching.